The first thing most people know about Venus is that it's hostile. At the surface, it's 900 degrees, hot enough to melt lead, and has 93 times Earth's atmospheric pressure. Certainly, it's no place for humans. Up in the atmosphere, though, at about 30 miles, the pressure and temperature both conveniently drop to Earth-like values, about 120 degrees at 1 Earth atmosphere, or 1 bar. On Mars, even the most optimistic temperatures and pressures are too low to naturally support the human body. This means the atmosphere of Venus is actually the most Earth-like place in the solar system. There are two problems with this, though. The atmosphere is made of carbon dioxide, which is unbreathable, and of course we need to stay 30 miles off the ground somehow. Conveniently, though, these problems work pretty well to solve each other. Carbon dioxide molecules are heavier than the nitrogen and oxygen molecules in breathable air, so we can effectively use it as a lifting gas. It'll hold just more than a pound per cubic meter, so a large vessel of breathable air would act as a fantastic habitat, supplying air, shade, and even a surface for solar panels. Venus also naturally offers protection from solar radiation, even at this high altitude. The thick atmosphere is able to scatter and absorb enough high-energy UV radiation to offer the same protection that Earth does, even though it lacks a magnetic field. Mars has neither of these protective measures, which makes radiation one of the greatest challenges that colonization efforts currently face. Another big challenge when it comes to Mars is power sources. Ignoring the dust storms, Mars only receives about half as much solar energy compared to Earth, but Venus receives twice as much. Venus also has much stronger winds than Earth, which circle the entire planet in only a week. Martian winds are fast too, but in such a thin atmosphere, they barely pack any punch at all. Venus even offers constant, unlimited thermal energy, easily accessible below the clouds. Mars just offers no power sources that are sustainable without drastic measures of equipment, which is expensive to transport and difficult to maintain. Mars does have water, though, a vital factor for colonization efforts, which Venus lacks. The cloud cover, unlike Earth, is made of sulfuric acid, which is hazardous, but it's also one of the most important chemicals used in industry here on Earth. It's commonly used to make fertilizers conveniently, and chemically speaking, could work as a source of water and oxygen too. It's also not much of a hazard in the first place, because while it's extremely corrosive, it's also completely unreactive with numerous different plastics that we already mass produce here on Earth. Even on the fundamental levels, Venus pulls ahead. It's almost the same size as Earth, so its gravity comfortably supports the human body, while Mars threatens us with microgravity. It's also much closer to Earth, offering an optimal path merely half as long as to Mars, and about 36% more often. So, with large aerostat vehicles filled with breathable air, colonists could circulate the clouds of Venus with a level of comfort and safety unattainable on Mars, and could study the surface up close. The main goal behind planetary exploration is to find places hospitable for life, either in search of new life or in prospects for human colonization. What makes this hard, though, is that most planets in the universe are too far away to study thoroughly, so our understanding of what we're looking at is limited. It's hard to know which clues to look for, and what they tell us about these worlds. Venus offers us a world in our reach that's seemingly so similar to Earth at first, but reveals itself to be so different when understood more completely. Originally, we thought Venus to be much like Earth, but with the first missions ever to visit another planet, we learned entirely new ways that a planet could be, and that Venus was actually very different. Finally, understanding the mechanisms behind these differences opens up a clearer view of these other distant worlds. Within just the scope of our own solar system, Venus still offers an unbeatable opportunity. Nearly all of what we know about the inner workings of the planets and other planetary bodies comes from evidence that they display on their surfaces. Earth's surface revealed plate tectonics even before we had a better view of it than with our own maps. And Mars has revealed an entire history of liquid water and atmospheric evolution, all before even a single sample has returned to Earth. Venus's surface happens to make up more than an entire third of all the solar system's surface area, and half of the planets. Imagine how many different things could be waiting undiscovered across this world alone, and what incredible science we could pull off, with people seeing it from just 30 miles away, rather than over 30 million. Even in the limited scope of Venus itself, though, there's still so many important questions that remain unanswered. As stated by Dr.
And
Paul
how we would
Byrne,
tackle them. But one of the things, for example, is we don't know what the rocks are made of. It seems like a pretty basic thing. What's it made of? Don't know what the interior is like. We don't know how active it is. We don't know how it gets its global cloud layer, which shouldn't, we think, hang around all that long. We think that the global layer of sulfuric acid clouds would get broken down by sunlight. Like, how come it doesn't have a magnetic field that it generates itself? Why does the atmosphere take about 7 days to go around its own axis, but the planet takes 243 days to go around its own axis? How is it that you can make some terrains on the surface look exactly like stuff on ancient parts of Earth, and yet have some places that are brand new? How come there's so few craters? There's fewer than 1,000 craters on Venus. That's kind of weird. Basic questions tied to just what it is and what it's doing.
Venus has so many qualities and opportunities that align for us between aspects of exploration, colonization, and science that it feels impossible to think that one day it wouldn't be at the core of our efforts to become a greater humanity. It feels hard to think even that that day is far away from now, and why should it be? Venus is a place out there for us, and although it won't be the first, I think that one day we'll probably wonder what we were waiting for.